Well, hello everyone, and welcome back to Adrian's Digital Basement 2. This is a super mini mail call episode, and I have a bunch of small stuff here that has been accumulating. There are a few big boxes as well, but I think today we'll go into the small boxes. All right, the first little package we're going to open up, it comes from friend of the channel, Bong, from Milpitas, California. Hi to all my California viewers. I know exactly what this is. Bong sent in something previously on the channel and there was a bit of an error on the last one, and this is a replacement for that. It's a little handmade project that had a little small error when it was assembled. And we have the little package here, and here it is. This is the corrected PC Sprint. You can use the first one I sent you after you fix the diodes or on your PC Junior. And then again, sorry for sending you the first PC Sprint with the wrong diode orientation. As always, love your videos, Bong. Thanks very much, Bong. So let's take a look at this. And unlike in the last video, I'm gonna grab a motherboard and we're gonna test this out. So what the PC Sprint is, and here it is, and that's just some packing material. There it is. Essentially what this does is you put it on your XT motherboard, and using this new crystal oscillator here, which doesn't appear to be soldered down, so I will do that. What that does is, using this extra clock generator and this extra crystal oscillator here, as far as I'm aware, it allows you to select between 4.77 megahertz and a turbo speed, I think 8 megahertz. And the reason why this crystal is not connected here is because you could potentially swap this out for even faster operation. So I went ahead and I grabbed an XT motherboard. This is a clone one, but it's gonna work perfectly on this. This is the chip on this motherboard that does the clock generation, and this will fit on here because the board goes this way, but I'm assuming on actual real motherboards, not these clone ones, that this part is in a different location on the board where this little PCB can fit a little bit better. What I need to do first is solder in this crystal oscillator. And I think what I'm going to do is I'm just going to let it kind of hang there in the wind so I can more easily remove it, because we're going to try some different frequencies or crystals to see how fast we can make this motherboard actually go. All right, so there's a notch on this little PCB, as is there on the motherboard. So we're just going to pop this in. Just want to make sure that nothing is touching underneath, and it looks good, and it's correctly in the socket as well. And then what we need to do is put this little clock generator here, which happens to be an NEC part, into this board. So the reason why we're going to have two is because it's selectable between this one, the stock one, which is just wired up to the stock crystal oscillator on the board. That will give us the 4.77 megahertz. And I assume switching this jumper here is going to engage this one with this crystal oscillator, which should run the system a whole lot faster. Now, when it comes to this particular project, it was something that was, I think, outlined in a magazine or a newsletter or something way back in the day, and was a quick and easy way to get your XT or even your 5150 or PC Junior running at a much faster speed. And a lot of these motherboards, obviously these chips here have to be able to handle that faster speed, but I think it was the case that a lot of times that just worked. And when you saw Turbo XT motherboards, essentially they had just taken this chip or this circuit and incorporated it right into the motherboard and had like two of these chips here with two crystals or something along those lines. I probably got a bit more sophisticated later on, but I think early on they really just replicated this circuit right here on this top edge of the motherboard. Okay, so I grabbed an XT IDE, I grabbed a CGA card here. It's plugged into a power supply. Let's just first see if this thing is actually powering on right now. I don't know how this jumper's set on the PC Sprint, but this definitely was a non-turbo motherboard. Oh, and you can see it only has a small amount of memory. All right, the system is booting. I had to switch out the ROM chip. The original one that was in there was this, and I don't know, it was misbehaving. These extra chips that were in here, by the way, are basic. And now the system is actually working. It's counting up to 256K RAM, and there it is. The system is working, and we're running actually already in the turbo speed at 7.6 megahertz. I do have a V20 in here, by the way, so that can obviously handle that speed. If we turn this off and we switch the jumper to the other two pins, my assumption is it's going to use the slower speed, or it's just not going to work at all, I guess. Let's go back to those other two. Okay, so definitely it's initializing the system, so I don't know. What if I try to change this jumper while the system is running? Oh, okay, just removing that jumper, I think changes it to stock speed. So let's see here. should be at 4.77 megahertz now. Maybe, come on. Boy, this is exciting content here. Oh, yep, there we go. 4.797 megahertz. So that's pretty sweet. This is a great little upgrade, and this particular motherboard at least seems to function at the faster speed. So there it is. Essentially, we take it off and we're at 1.94, so it's not quite doubling the speed, obviously. And here we are at 3.06 megahertz. That's the equivalent speed, by the way, in this program as an AT. So if this was in a 6 megahertz AT, then the CPU speed there should be around 6 megahertz. So this is still half as fast as the IBM 286 or the 5170 when it first came out, but it's still a pretty nice upgrade for this system. And I think the thing to do now is let's see how fast we can go by upping the crystal that's on here. Alrighty, so what I went ahead and did is I socketed the crystal there. So there's no jumper installed. I currently have that off. So we're running at the stock speed. So let's go check out speed 200, which is an old version of the landmark test. And then I have two crystals here. I have one that's 25 megahertz and one that's 36. We're going for like maximum overclock of this system. So this should show us 4.77 megahertz or thereabouts. Because the jumper's not on here, this crystal's actually not being used right now. So when we put the jumper on, it should come into effect. There we go. Let's make sure this is still working. Yep, there it is, 3.06 megahertz. Okay, cool. So with that off, we can safely remove this crystal, I think. Nope, it caused the system to crash. Okay, well that does need to be in there, but we are gonna install, I'll turn the power off here. We're gonna install the 25 megahertz crystal. The one that's installed now is 22.18 something or other megahertz. So this should be slightly faster, and we will put the jumper on just to see this thing boot in its turbo speed. Uh-oh, we got system error 2. So maybe this is somehow too fast. Let's try that again. Oh, look at that. Okay, well, if I pull the jumper off, should work, maybe. Okay, it's gonna run at the stock speed. Now, the one thing we have to consider is that all of the chips on this motherboard, at least the ones on the original XT motherboard, were designed only to run at like, I think up to 5 megahertz. So trying to overclock them like we're doing here, look at that. It's just instantly crashed the system and it rebooted, and yeah, it's not happy anymore. So I thought that 25 megahertz, which is what this crystal was, would have only resulted in a slight overclock, like should have been running a little bit faster than 8 megahertz or something. This is a 36 megahertz crystal. Let's just for fun see what happens if the system even posts at all with this thing. Hey, it's posting. I mean, it's counting the RAM. Wait, is this thing working reliably with, is that really 36 megahertz? Let me look at what I put in here. Yeah, 36 megahertz. So what speed would that give us? Something a lot faster. It's possible that that crystal, the 25 megahertz one, is just damaged. Like I took it out of a little bag. I don't know if it's works or whatever. The jumper's on there, so we should be running at the faster speed. Let's see how fast this is going. So yeah, maybe this 25 megahertz crystal is just bad and causing it to not be happy, or maybe 25 megahertz results in some resonance that causes it not to work. Or maybe it's working very slowly right now. Oh, okay, we've underclocked the system. Well, that would explain why it works. So if we take the jumper off, we're gonna speed up a little bit. Oh, wait, I'm confused because I thought that the jumper on ran at the faster speed and the jumper off ran at the stock speed, but it's off now, and definitely 4.43 megahertz is much faster than we were getting before. Remember we were getting like 3 megahertz before? We'll just retest. All right, so I'm a little confused. Maybe I should go read the documentation for this. This is like, I'm not RTFM, I'm just stuck it in the board. And we're seeing how this goes. So incidentally, while we're waiting here, oh, there it is. 11 megahertz. This is one fast XT and it's freaking working. Wow. That is super cool. I mean, I don't know if this Z80, or not Z80, I don't know if this V20 processor is good to go, but the system appears to be working. Now we only have 256K of RAM on this system, so I don't have enough memory to run like Check It, for instance, or any other benchmarks for that matter. And I have another XT motherboard that has full 640K on it, but unfortunately that chip right here is the same exact motherboard. That chip's not socketed on that one, so I can't easily test it. But look at this, 11 megahertz. If I put this in a PC Junior and it runs at 11 megahertz, that is a very, very respectable overclock. Very nice. Now I do have a little utility called MIPS on here, which should do some, I don't know, rudimentary tests here. And there's the stock PC speed. And if this doesn't crash, we should get a multiplier for how much faster it is. So this machine is now running at 2.23 times the speed of the original PC XT. Or the original PC, at least with that general instruction test. Oh, and I mean, of course, the V20 itself is going to result in a little bit of a speed increase as well. Oh, you know what? I keep saying that this is a V20, but the chip that's in here is just a regular 8088. It's just made by NEC, so that's why I was thinking it was a V20. So putting in a V20 would, of course, give us an additional speed boost, but we're already rocking the speed of the original PC. So you have to imagine that, like, back in the day, yeah, look at that, 2.28 times the performance. That is amazing. You know what? Let's put this jumper back on. Make sure this thing is running at stock speed. There we go. Is it crashed? No, it's not crashed. Okay, here we go. So you have to think that this little kit, I don't know what this costs, like if you could buy one of these. Oh, look how slow this thing is running. Oh yeah. So this thing is like acting weird because it's currently running even slower than stock speed. So I don't quite get that. So, okay, well, anyways, back to what I was saying. Imagine that you could buy this little board, probably inexpensively, the extra clock generator and a couple crystal oscillators, and then you could more than double the speed of your PC XT. I mean, that's a significant speed boost. You might have to like swap out the processor, for instance, or to be honest, if you bought something like this, like one of these XT boards here, well, obviously this one just works. This is going to be later chips than on the original PC, so perhaps this is more amenable to running at a faster speed, but either way, yeah, I don't know. I think it's a pretty amazing thing. What about this middle position? Well, that crashed the computer immediately. Continue, yes. Now let's see if this powers up in that middle jumper position. It's attempting to post. Oh, incidentally, I put the these ROMs back in, and it is kind of a basic. Look at this, cassette basic by Sunup Computer. You know this is like a total ripoff of IBM's basic, and they just switched out the banner there. All right, so in the middle configuration, we're getting 10.9 megahertz, or that's roughly the same as with the jumper removed, right? Yeah, okay. Then I don't really understand what's happening with this thing. Why is it running slower? I couldn't tell you. And then there's this final jumper here, which just crashes the system entirely. Let's see if it posts now on that position. So I have it completely over to one side. Let's zoom up a little bit. So the jumper right here. Nah, the system won't even post. Okay. So either way, this system is running at a really nice clip at 11 freaking megahertz. All right, definitely we are still working. So the other one that Bong sent in will be in these boxes behind me there. See that box back there? I have like a stack of mail call items that have kind of come in, and I haven't, I showed them on a video, but I didn't use them yet. And I need to go reverse a couple of the resistors or diodes that are on here to make that one work, and then I can put it in my PC Junior, which if I can get this kind of speed out of it, that is a massive, massive speed boost for that machine and should make it faster than even like a Tandy 1000 EX, for instance. I think the EX only runs at 8 megahertz, something like that. So that is really cool. And then a V20 processor, of course, would give you even additional speed boost to really amp up your PC Junior, for instance. Now the PC Sprint, the one that's on this motherboard here, is an open source project. And if you just look for PC Sprint, here it is right here on GitHub. And I think it's got all the PCB files and stuff like that, so you can make your own. And here's the quick introduction. Oh yeah, so look, just like I thought, on the IBM like PC 5150, 5160, that clock generator chip is over here on the side in a much better spot, which means it doesn't interfere with your card slots and stuff like it does on this thing. And this talks about how this thing works. So it's a clock divider or generator. That's the Intel chip that's on there. And the motherboard crystal at 14.318 is divided down to end up at 4.77 megahertz. So the PC Sprint adds a turbo switch as found on later PCs to disable the higher clock rate and hardware reset button. to enable a higher clock rate. Oh, and a reset button. Okay, those extra 2 pins, people were probably screaming at their screen, is a reset button. So the original IBM PC didn't have one. So I think what was common, if you had a PC Sprint, you'd have a little like slot cover on the back, you drill 2 holes, you'd have a toggle switch for turbo, and then you would have a button, like a momentary button for reset. So you'd have to power cycle that computer constantly. And then right here, if you use a 22.11 megahertz crystal, which is what was included here from Bong, that gives you a clock speed of 7.37 megahertz, giving you an impressive 64% processing speed increase. Faster speeds may be possible, but are not recommended for stability reasons. Well, yes, like I said, on the original PC 5150, 5160, those motherboards, the chips on there are really designed for 5 megahertz. So even running them at 7 is like a big overclock. And I think this clone board here is from the later 80s and probably has a bunch of chips, which I could see are made by NEC, that probably are spec to run at like up to 8 megahertz. So the fact that we're running at 11 right now is a little bit of an overclock on these, but they're not even warm. I'm touching them, which I know you can't see, and the thing is still working. It does say in the article here that if you have your original XT, you gotta swap out the processor for a -2 variant, which I think is good up to 10 megahertz, or a V20, which will speed it up even faster. All right, so there we go. Thanks very much, Bong, for sending in the PC Sprint. And there we go. I got it running up to 11 megahertz, which is freaking great. I think for now, I'm just gonna take that crystal out. We'll stick in the original one that Bong sent in this little 2-pin socket here I put on the board. And then I just need to find my other one, fix it, and then I can accelerate 2 of my XTs. If you want to make one of these yourself, I'll put a link in the description to the GitHub repo. Alrighty, the next package, I've already opened it up, and it's a couple t-shirts. Let's just quickly take a look at these. These t-shirts come from Brad over at the channel TechTimeTraveller. That channel is pretty awesome. Brad really is into like super old systems and buys these like really obscure random computers and gets them working on his channel. So I absolutely love it. He had a little bit of a breakout hit with a Miniscribe brick video, a retrospective about that company. Anyhow, Brad has some merch now for his channel, and these are some of the shirts he's got here. Southwest Technical Products Corporation. So this is the company that made that 6800 PC, and it's got a little thing on the front there, and on the back, there it is. The logo, the full-size logo. I think this was like a replica of a t-shirt that they actually had back in the day. Now, I asked Brad if he could maybe make some new versions with this big logo on the front of the shirt as opposed to the little small logo. Personally, I'm not really a big fan of like the little logo on your front and stuff on the back. I'd rather just have nothing on the back and the full-on system logo on the front. I can't zoom out anymore, so this is quite big, but it looks really good. And there it is, a Gildan shirt. These are good quality shirts I found. So that's pretty awesome. And what is this one? This one here says OSI, which is another old school company. And there's the back, Ohio Scientific, another computer that made amazing old computers. And I think that from the Star Trek game that was available for that computer, these are some of the custom characters that it was able to display. So thank you very much, Brad, for sending in these t-shirts to the channel. And you, my viewers, if you haven't seen Brad's channel, TechTimeTraveller, I'll of course put a link in the description. Highly recommend it. His videos are quite funny and very entertaining. All right, next up we have a package here from Ron at Ron's Computer Videos. He's got a little YouTube channel where he shows off cool Mac stuff a lot of the time. Now, Ron's been working on some cool little PCB type projects that he often sends me, and I think that's what this is right here. Let's switch to the other camera view. So, oh yeah, here we go. Yes, we have, that's Ron with his little logo. So it's just a little CR2032 holder and a switch with a diode and then a wire. So, you know, I often just take one of these holders and sort of solder a diode right onto it and, I don't know, put hot glue or heat shrink on there. Well, if you don't feel like kind of hacking together a little solution like I do, you can have this, and then there's a little header right there. You just run wires off to wherever on the motherboard you need to connect it to, and then you can just stick this on the inside of the case, somewhere accessible so you can swap the battery, and then if you do want to shut the battery off for long-term storage, you can easily do that. Oh, that's really cute. Look at the back there. No leaks. Yeah, indeed. There's the URL right there, ronscomputervids.com. And it looks like Ron has gone ahead and sent me a couple of these. Yep, those two are the same. And then we have this, which is a little TTL video adapter for the Mac Classic SE and Plus. I think the main gist of this little project here, oh, look at that on the back, that's really cute. It allows you to use an RGB to HDMI, or I guess any kind of monitor that does support the frequencies the computer uses, and it buffers the signals. So the horizontal, vertical sync, and then the video signal as well are buffered. That way you're not connecting something like the RGB to HDMI directly to the output of the motherboard, which can cause a little bit of interference depending on the kind of wires you have. Sometimes you get a little bit of waviness and stuff in the picture. So this little project here allows you to eliminate that. This is his version 4, and I think Ron's working on even more advanced one with some inverting capabilities and stuff like that. So cool, thanks very much Ron for sending these in. I actually think I'm gonna use one of these buffered adapters here on my Mac Classic, the one I constantly bring out that has the green screen. I would like to have permanent video output on that thing that I can connect up easily to an RGB to HDMI, and this little buffer chip will just ensure that that is a little bit safe, and then I could just like double stick tape this inside the computer nice and easily. Anyhow, thanks again, Ron, for sending these little adapters, and if you're interested in these, of course I'll put links in the description below. All right, next up we have a little package here. It comes from a viewer, Brian, and I think there's a letter here. This was hand delivered to me at VCF Southeast in Atlanta. So let's take a look at what this is. I haven't opened it up and I don't know what it is. Thank you for your purchase and helping support the future of this project. As a reminder, there's a project page located at GitHub. Please refer to the documentation there for important information about configuring and using your iDone cartridge. iDone cartridge. I don't know what this is. You may have chosen to include a micro SD card for your Raspberry Pi in the order. If so, it already loaded with the latest software. If you're using blank media, please be sure to download the latest image file and use it. The link to download in the quick start section of the README file on the GitHub. All right, and there's instructions on assembling it, and looks like it uses a Raspberry Pi or a Pi 02, so probably a Pi 0 or a Pi 02. And that appears to be it. I don't have anything else in here. Oh, what is this? I think the best thing to do is to just go and look this up on GitHub to see what exactly the iDone cartridge is. All right, I think this is it here. So iDone for the C128, home of the iDone cartridge where you find the latest software. What it does, hopefully a demo is worth 1,000 words. Well, let's see. Hardware, it's a Propeller One microcontroller provided the latest hardware interface between the C128 and a Raspberry Pi that runs a customized Linux OS. The cartridge is designed to work and fit best with the Raspberry Pi 02. However, any recent Pi can be made to work. It's funny, I have one single Raspberry Pi 02. I have not been able to get my hands on any others. I know they kind of come into stock periodically, and I did pick one up recently when it came into stock, but to be honest, I don't really have time to kind of be searching the stock checkers all the time and grabbing orders, and we don't have a Micro Center local to me. And last time I was in Atlanta for VCF, I stopped by Micro Center and they only had Raspberry Pi Zeros, the original one, so I picked up one of those. But apparently I just heard they started selling the 02 again. Anyhow, there it is assembled, and yeah, it looks like it's got this large microcontroller, a 40-pin one, and then you plug in the Pi to that. Sort of hangs off there, and then 3D printed case where the Pi is visible, and looks like indeed you can use the larger versions of the Pi. It just sort of hangs out of the cartridge. Well, I think we're gonna have to go try to watch the video here because it doesn't really say exactly what it is. All right, I just finished the video on this project, and it's actually pronounced Eden, not iDone. I was saying iDone, Eden. There's quite a lot going on with this project, so I'll kind of try to summarize it. It's a cartridge for the C128. When you turn it on, it gives you this really fancy DOS shell, which is kind of like MS-DOS. That allows you to mount virtual drives besides like the physical 8 and 9 IEC drives. You can have virtual drives, and you can navigate with file managers. You can load software. It supports all sorts of graphics modes. It allows you to connect to Telnet BBSs, of course, through the Raspberry Pi. It allows you to connect to Linux and use your C128 as a terminal emulator, VT100 terminal emulator. You can even load an ANSI font, so you get the correct fonts for those BBSs and for the terminal mode. And it allows for Lua scripting, where the scripting is actually running on the Raspberry Pi side and then feeding back into the C128. So you can do high resolution graphics and the Mandelbrot calculations, for instance, and that is all accomplished at pretty quick speed on the Pi, but then it's using the C128 as your interface. All that DOS shell stuff works in 80 columns and 40 columns. You can even run it in like 64 mode, so with Go64, and load up 64 software off those virtual drives, including tape software, and it all happens super quickly. And there's no connection from this cartridge up to the IEC port like some of the other emulator cartridges. It seems to be able to do that completely inside the cartridge port, emulating those disk drives and stuff. I don't know how good it is at loading D64 images, like if demos work, the ones that use fast loaders and normally need a Pi 1541 to work properly, or a real disk drive. But either way, it seems, well, really, really capable. And if you're a big C128 fan, this seems like a really, really cool project. Now, unfortunately, I'm really backed up with PCB building projects like this. I have so many to make. In fact, I know I have one just sort of sitting around right here that I had wanted to make. It was a diagnostic cartridge for the 64, but I haven't even gotten around to that. I have some other bigger projects that are going to take time. So I don't think I'm going to be building this up right now. This will just go into my project box for future builds. But definitely, like I said, if you're a 128 fan, check out the GitHub repo and that video so you can see all about this, because I think there's a lot going on here with the Eden project that's pretty darn cool. So thanks very much, Brian, for finding me at VCF and giving this to me. And let me grab the next item. All right, speaking of VCF, here's another little thing I picked up at VCF, and it doesn't have a box, but let's just take a quick look at this. So what we have here is a Sven Peterson project called the Potato, and it's a little aid for soldering onto DIN connectors. This is freaking amazing. So a friend of mine, Dan, had this made up, and I guess he had several of them, and he wanted me to have one. And I've never had a little aid like this, and as usual, Sven Peterson makes some amazing stuff, like the diagnostic test harness, of course, is one of his most famous things that I use constantly. And as you can see here with the logo, open source hardware, which is amazing. So the gist with this little thing is you can notice it is two PCBs. Let's see if we can get this to focus here. Two PCBs stacked up, which means you take your DIN connector when you're going to solder and you take off all the housing stuff and you slide it into this, and it just holds it perfectly so that you can really easily solder it. I have to use those little helping hand things where you clip onto things to try to grip it and then, you know, carefully solder it. But this thing is great. And it has the little pinouts here for 64 power, AV jack, VIC-20, IEC bus, and 1541. And I mean, of course, these types of DINs here aren't just used for those things, but, you know, he just printed that on there handily. And on this side here, we have TI-99, a couple different versions. DIN 3180, I don't know, this must be a European thing, maybe for speakers or something. And then we have Sega Master System and Genesis and the Atari 800 right here. All super handy. Let me grab a DIN so we can demonstrate how this thing works. All right, so here's the DIN connector, is what I'm talking about. It's unused, unconnected, anything. So if you pull it all apart, all this stuff comes off, and what you're left with is just this part right here. And then what you can do is find the appropriate spot on here, like that. Now, of course, this DIN has 2 less pins than this one, but that's not a problem because it still works perfectly. And there it is, it's held in there really nicely, and it's perfect for soldering. I really love this. So yeah, Dan, thanks very much. And Sven, thank you very much for making this. What a fun little thing. And of course, open source hardware means if you want to have one made, you can get it made at any of the PCB manufacturers. You just get a couple little nuts and washers and things there, and you can make your own one of these. Really handy. Great use of some inexpensive PCB manufacturing. All right, the next and final package we're going to look at today is this International FedEx package. And unfortunately, I've had this for about 2 months, so I apologize to whoever sent this in. This package comes from Ivo in Bulgaria. So hi to all my Bulgarian viewers. That is freaking cool. I don't know if I've ever gotten anything from Bulgaria before. All right, so let's see what we have inside here. Ooh, okay, couple wire harnesses. Very nicely packaged, no letter or anything. There may be an email about this that I don't recall. Oh, right. Okay. Oh, I'm gonna have to make a special video about this. So what we have here is a soft card for the Apple II, and as you can see, this has an ESP32 right on the card, and video and some bus transceivers, a little bit of space here. This harness here, I'm pretty sure this is just a video cable that goes from the Apple II itself and it plugs into the input here, and see there's a video in and out, so it actually does a pass-through. This project is freaking cool, and as I said, this deserves its own video entirely because there's a lot going on with this. If I recall, this thing allows you, via, of course, the ESP32, to emulate other types of computers on your Apple II, including, if I recall, the Macintosh. But keep in mind, this is not just an ESP32 sort of doing that. This is interfacing to the Apple II itself, and it's able to use the ESP32 to actually talk directly on the bus. This is very similar to the Apple II VGA and CPM card that I recently showed off that does the same thing, but it's using a Raspberry Pi Pico, and the Pico is talking on the bus directly, and it's emulating, well, the CPM soft card and also a VGA card, which of course is not a real card, but it's doing that by snooping the bus and stuff like that. I think this allows for similar stuff. There's an SD card slot here, and I mean, the main, I guess, thing about obviously running like Macintosh software on your Apple II, as cool as that is I'm pretty sure that's happening over composite video. So it's not gonna look super great, but to be honest, I'm not totally sure about that. Let me find the email about this thing so I can talk a little bit more authoritatively about it. I don't think this is open source hardware, and I don't think this is actually out yet here. Oh, it does say here, Apple II Forever, version 1 Rev 2. Oh yeah, look at this, by the way. Speaker pass-through. Oh, I kind of recall that this has some sound card emulation stuff going on as well. All right, I found the email, and there's a thread here on Apple Fritter that talks about what this card can do. So of course, you can get on the internet through the Wi-Fi, you can listen to internet radio and play MP3 files from the SD card or stream for a URL. The playback remains in the background while running other Apple II programs. You can play videos stored on the SD card or stream from a URL. Maximum resolution is 320 by 240. You can run Doom, of course. Emulate a Mac Classic. The ROM and floppy images are on the SD card. Emulate Sega and NES. Game ROMs need to be on the SD card. Rudimentary 80 by 25 mode. Command console with DOS-like commands. There's FTP client. It supports Apple II joysticks. Joysticks can be used for Doom, Wolf, Sega 3D, etc. So it can use the actual Apple II's native joystick for those. You can emulate a mouse with a joystick. Supports grayscale mode for monochrome monitors, which maybe could look a little bit better for some of those modes. In progress, support for the Apple Mouse 2. In progress, horizontal vertical centering of the picture and overscan, underscan adjustments and persistence, and over-the-air firmware update capabilities. And there is a picture of the card, which, as you see, we have right here in front of myself. And scrolling down a little bit, here it is running the Macintosh emulator that then is emulating an Apple II. I know it's a bit of a misnomer to say that like the Apple II is emulating the Mac, because of course it's happening on the ESP32, which is a pretty powerful little 32-bit microcontroller, but it's double emulation. Now, looking at this thread, by the way, it looks like this stuff has been happening for a good number of months, and I really don't know if, well, anyone else has this card. So I really obviously need to get my butt in gear and make a video about this. I can't believe I've been sitting on this for almost 2 months now. And it looks like in July there was a group buy for this card, so that's pretty cool, and it's talking about some more of the capabilities. Oh, and it looks like this thing now has NTSC 50 compatible mode, which is kind of like what we have on the Kawari for the C64. I made a video specifically about that, so that's pretty cool. You get the extra resolution, but you still get a color picture on things like the Commodore 1702 monitor and the Apple color monitors and stuff like that. And here's a post from later in July, and it looks like the Sega Genesis emulator is not going to work on this thing. Apparently there's just not enough performance in the ESP32, and it runs at half speed. Unfortunately, in this video, I'm not going to have time to explore this. I'm going to have to explore it off camera and then make a separate little video about this. And we'll check out the latest firmware, since the stuff I have on here is now about 2 months old. But I absolutely love these software-defined cards. These projects like this blow my mind, and I think there's so much potential with them. My first exposure to a software-defined card for the Apple II was that VGA card, and then this is now the second one, and I think there's other people working on other type cards. And in fact, the Eden project we just looked at for the C128 is also mostly a software-defined project, where it uses, I think, a microcontroller as the interface between the Raspberry Pi and the main computer. And if you think about this, it's obviously just using a microcontroller directly with some level shifters to do that same stuff. And then the microcontroller also creates the video and the audio sound output of this card. Anyways, Ivan, thanks very much for sending this in all the way from Bulgaria. Sorry it took me 2 months to get to this. I will be reaching out to you and getting this working in the system so I can learn how this works, and then I can make a video about it. And yeah, I have a lot of other videos that are in the pipeline, similar projects like this, that I kind of need to try to get my head wrapped around so I can turn them into videos that are interesting to you, my viewers. So I think that's going to be it for this mail call video. Huge thanks to everyone who sent stuff into the channel. I still have a bunch of stuff. There's boxes here and stuff on the floor that I need to get to and do future mail call videos. But yeah, this is going to be it for this one. So thanks again for everyone who sent stuff in. And if you liked this video, thumbs up. If you didn't, you know what to do. Don't forget to check out the links in the description to all these various awesome projects. And huge thanks to my patrons. Their names are scrolling up the side of the screen. They literally make this possible. So I really want to thank them for all the support they give me and the channel. It's incredible. It blows my mind. And my patrons do get early access to videos, plus some special behind the scenes content, stuff like that. And yeah, that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.